Okay, so here's part 2 of the practice final exam. Question 14. We have the cube root, see the 3 there in the hook, the cube root of negative 8x to the 6y to the 9th. How do we do a cube root? We got to break down what's in there. So 8 is 2 times 4, and 4 is 2 times 2. And so then, let's break that all down. We have the cube root of, so that's going to be negative 2, negative 2. So we'll make those all negative. 3 negative 2's make negative 8, don't they? 3 negatives. And then break down the x's. We have 6 x's. 1, 2, 3, 4, 5, 6. And then y's, we have 9 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then, now we ship stuff out. How do we do it? Well, the 3 in the hook means it's a 3-for-1 deal. That's how you ship out. Whatever number's in the hook, it's that deal. So it's like shopping at Target, and it's a 3-for-1 deal. So 3 negative 2's in, ships 1 negative 2 out. 3 x's in, ships an x out. 3 x's in, ships an x out. 3 y's, ships a y, 3 y's, ships another y, and 3 y's, ships the last y. What do we have? Minus 2x squared, y cubed. That's the answer. You could save time, really, if you wanted. You could just divide this power by 3 and divide that power by 3. 6 divided by 3 would be 2, and 9 divided by 3 would be 3. Get your x2, y3 that way. That could save time if you want to do it that way. It's quicker. Okay, so 252, let's break it down. That's 2 times 126, just use your calculator. 2 times 63, that's 7 times 9, 3 times 3. Okay, so broke down the 252 into, what is it, 2 2's, a 7, and 2 3's, right? 2 3's, a 7, 2 2's. There's the guts of a 252. Now, a to the 8th, b to the 19th. What's in the hook here? There's nothing in the hook, right? Which really means 2. It's a 2 root. So I'm going to leave the a to the 8th as a to the 8th. And the b to the 19th, I'm going to make that b to the 18th and one more b. Right, that's how we do b to the 19th, 18 and one more. So now, like I said, there's really a 2 in the hook here. So it's going to be, it's a 2-for-1 deal. So here we go. 2 2's in, 1 2 out, in addition to that negative sign that's already out there. 2 3's in, 1 3 out. They will multiply when they come outside, just like they were inside. Now, a to the 8th, it's a 2-for-1 deal. Remember, again, there's a 2, an invisible, understood 2 in the hook. When there's no number in the hook, it means 2. It's a 2-for-1 deal, so if we have 8 A's and you get 2 for 1, we'll get out 4. And 18 B's, 2 for 1, get out 9. What's left inside? The 7 and the extra B. Do you see, that's why I took the odd number of the 19th power, and I made it 18 and 1. So whenever you have an odd power, just make it even and 1 more. That way you can cut the even in half easily. Okay. What does that give us? Minus 2 times 3 is minus 6. A to the 4th, b to the 9th, root of 7b. There's our answer. Okay, number 16. We're supposed to multiply. So remember when we multiply roots, like if I have root 7 times root 7, that's going to be plain 7, isn't it? Because it's really root 49, which is plain 7. Or if I have root 3, that's plain 3, because it's root of 9. If I have root 97 times root 97, it's plain 97, isn't it? So whenever you have 2 of the same roots, that produces one of those numbers outside the root. Okay. So here we go. Boom, boom. So root 15 times 2 root 15, what happens? 2, and then root 15 makes a plain 15. And then root 15 times 1 is just root 15. He's done. And now I'll take the minus, that minus is his, minus 5 root 3 times this. Now what happens? Outside numbers multiply outside numbers. So it's minus 10, right? 5 times 2, 10. Root of 45. That's the 3 times the 15. And then we go here, minus 5 root 3 times 1 is just 5 root 3. Okay, now what do we do from here? Well, this 45 right here, this is 3 times 15, which is 3 times 5. So there's really 2 3's in there, isn't there? So here, let me take it a little slower. Bring this down. 2 times 15 is 30. Root 15 minus 10. Now the root of 45 is 3 3 5s. So 3 3 5 minus 5 root 3. Now those 2 3's inside, send 1 3 out, and they're gone. So that gives us 30 plus root 15 minus, and then 3 times 10, 30, and the 5 is left inside, minus 5 root 3. And there we go. We cannot add or subtract any of those because they're all unlike terms. They're all different than each other. Like that. By the way, if you're wondering why I didn't do the 15, if you break down the 15, it's just 3 times 5. So there's not 2 of anything to ship out. But with the 45 here, when we broke it down, we got 2 3's, and so these 2 3's shipped out a 3 to multiply that 10 that's already out there. And it left the 5 inside. There we go. Okay, so this one they want us to write, it says right if you look here, rationalize the denominator. So that means we got to get rid of roots from the bottom. But first I would break down this 12. Always do that first, makes things easier. 4 times 3, 2 times 2. So this becomes what? Becomes 7 over root of 2, 2, 3, x. Right? 2, 2, 3, and then the x is in there also. Okay, and then the 2 2's inside. Ship 1 2 outside, and they're gone. So we get 7 over 2 root of 3x. Now, we can't leave that root in the bottom, so we multiply top and bottom by root 3x. What do we get? On the top, it's just 7 root 3x. Nothing special there. On the bottom, it's 2. And then what is root 3x root 3x? Plain 3x. Remember when we have 2 of the same thing in a root, out comes one plain one. And that's really, well, it's almost it. Let's just go 7 root 3x. 2 times 3, 6x. That's all we can do. That's our answer. We can't cancel these x's or the 3 and the 6 because they're in different worlds. These guys are in roots and these guys are out of roots. 2 different worlds, no interacting. That's our final answer. What did we do? We got rid of the root from the bottom. Okay, so number 18. This one's harder. When you have a root and plus or minus in the denominator. When you have a root and a plus or minus in the denominator, see, you must multiply top and bottom by what's called the conjugate, which means same as denominator, opposite sign in the middle. So you see, the whole thing is that we have a root and a plus or minus, in this case a minus, in the denominator. And the last one, look at number 17 here. We had a root, or even here we had a root, but no plus or minus. Do you see how there's no adding or subtracting? It's just 2 times root 3x. There's just times here in the middle, right? There's no adding or subtracting. So when you have adding or subtracting, that's when you got to use the conjugate, which is the same as the denominator but opposite sign in the middle. So I've got to multiply by exactly the denominator but the opposite sign in the middle. See, if this sign had originally been plus, then I would use minus top and bottom. You always use the opposite sign that you have in the bottom. So it has minus in the bottom, so I use plus and plus to do the problem. Okay. So how do we do it now? Put parentheses here. So basically it's going to be, this 4 is going to go there and there. 4 times 3 is 12 plus 4 root 11 over. And then in the denominator, 3 times 3 is 9. 3 times plus 3 root 11. The 3 stays outside because he's an outsider. He's not in the root. He's done. And then this guy will go to both. Minus 3 root 11. Minus root 11. Root 11. Plane 11. You see that? How those two made plane 11. Root 11, root 11 made plane 11. Okay, let's clean it up. See how these two cancel now? Plus 3 root 11 minus 3 root 11. Those cancel. That's why we use the opposite sign, because then we get those to cancel. So we have 12 plus 4 root 11 over negative 2, right? 9 minus 11, negative 2. Last step, we'll put the negative 2 underneath both of those, and then we can divide. We get what? Negative 6 minus 2 root 11. There we go. What did we do? We got rid of the root from the denominator. Okay, so we're going to multiply these two complex numbers. They have real and imaginary parts. They're complex numbers. Going to multiply them together. The main thing to remember as you do this is that anytime I squared shows up, that's actually negative 1. So we'll replace I squared with negative 1 whenever it shows up. Here we go. Goes to both those. The 6 multiplies the 6 and the I. So 6 times 6 is 36. Oops, plus 6I. He's done. And now the 9I goes to both. Minus 6 times 9, 54I. Plus 9I squared. Okay, so what does that give us? That gives us 36. 6I plus 6I minus 54I. What's that? Minus 48I? Yeah. Now, plus 9I squared. Now, remember what we just said about I squared? I squared is negative 1. So right there, I replace I squared with negative 1. I leave the regular I. I don't do anything with that. Just leave regular I. But I squared, we replace with negative 1 because I squared is negative 1. Okay, so where does that give us? Leave us 36 minus 48I plus minus 9, right? Positive times negative is minus. Now 36 minus 9, we can subtract those. Those are just whole numbers. What's that? 27 minus 48I. There's our answer. 27 minus 48I. So remember, I squared gets replaced with negative 1. Okay, so I'm supposed to solve this. It says solve. Oops. So how do you solve x squared with an equal sign? So you want to have on your sheet of notes for the final exam the game plan when you have x squared with an equal sign. What is it? Step 1, you've got to get a 0. Step 2, you can try to factor if you want, or you can do the quad. Negative b plus or minus square root of b squared minus 4ac all over 2a. That's what I'm going to do here. So step 1 is I got to get a 0. So jump this 8 to that side. And so what do we got? We got 5m squared plus 2m minus 8 is 0. So when that positive 8 jumped over, it changed signs to be negative 8. So now we can identify A is 5, B is 2, C is negative 8. So I'm going to do the quadratic formula, negative B plus or minus the square root, right? Doing this negative B plus minus square root of B squared. So that would be 2 squared minus 4 times A times C times 5 times C, which is negative 8 all over 2A. A again is 5. Okay, so there's the quadratic formula. Let's work it out now. So that's negative 2 plus or minus square root of 4 minus times plus times minus. It's going to be plus, right? Two negatives make positive. Use your calculator. I think it's 160 all over 10. Whoops, kind of scribbly there. Okay, so now, where do we go from here? This is negative 2 plus or minus the square root of 164 over 10. So I got to break down that root of 164. Use your calculator. 2 times 82, 2 times 41. Am I doing that right? Yeah, right, 20. Yeah, and 41 doesn't break down. So that'll be what? That'll be minus 2 plus or minus the square root of 2 times 41 all over 10. Right? The 2 2's and the 41. And then you know the drill, 2 2's in, sends 1 2 out. It goes right in front of the root and they're gone. So whenever you send things out of a root, it goes right to the front of the root, nowhere else. And so that leaves us minus 2 plus or minus 2 root 41 over 10. A little scribbly there. Now, can we simplify that at all in any way, shape, or form? Yes, actually we can. Got to be careful with this though. Basically, if these three outside the root numbers, if they're all divisible by the same thing, you can do it. Do all three of those numbers divide by the same thing? What goes into all three of those numbers? What can you divide them all by? 2, right? Now, if so I'll do it. I'll divide by 2, divide by 2, divide by 2. If any one of them couldn't do it, then we just stop and we're done. Like, for example, what if this number, instead of being a 2, what if this was like a 3? Oh, well then the three numbers, the negative 2, the 3, and the 10, they would not all be divisible by the same number. There's nothing that goes into all three of them. So I would just stop. That would be the end of the problem. Or what if there was nothing there? You might think, well, can't I just do the negative 2 and the 10? But no, because actually nothing there really means there's a 1, right? An invisible 1. And then we would have to say all three numbers, there's nothing that goes into all three numbers. So no, we couldn't do it. So I'm going to put it back the way it was. It was a 2. And so what goes into all three numbers? I can divide them all by 2. And so with that in mind, the final answer is negative 1, right? Negative 2 divided by 2 is negative 1, plus or minus root 41 all over 5. 2 divided by 10 is 5. 2 divided by 2 right here, this made 1. You can put a 1 there if you want. You don't need the 1. It's not doing anything. Those are the answers. Okay, so number 21 here. So what's unique about this problem? You know, what's hard on a final is it's all mixed up and it's hard to recognize everything. What's unique here is you want to identify that greater than, less than. Whenever you see greater than, less than, you know, anything like any of these kind of symbols. Getting kind of scribbly on that last one. There's a certain order of steps. Step 1, get a 0, which we have. and factor. So we got a 0. I'm going to try to factor this. Now, how does that one factor? Well, I can do the little diamond. What multiplies to be 8, adds to be 6. Multiply to be 8, add to be 6. What times what is 8? 2 and 4, right? Positive 2, positive 4. Multiply to be 8 and add to be 6. So that means it's x plus 2, x plus 4, greater than or equal to 0. Step 2, set each part equal to 0 and solve. So the x plus 2 alone, or the x plus 4, each part set equal to 0 and solve. So move that over there, so that would be negative 2. Move that over there, negative 4. Okay. Step 3. Put answers on the number line. So go to a number line now and put the answers. Now it's easy to make a small mistake at this point and go negative 2 is here and negative 4 is there. That's actually backwards, isn't it? Because, 0 is like somewhere over here, and negative 4 actually is further left, so you want to put negative 4 here and negative 2 there, like that. That's their true order on the number line. Watch out for that. Okay? And now put the answers on the number line and check x equals 0. We're going to get true, false, true, or false, true, false. Check x equals 0 on the original, I should say. So here we go. So here's x equals 0 is right here. So when I plug 0 into the original, so I'll write it out, x squared plus 6x plus 8 greater than or equal to 0. Plug in 0, you get 0 plus 8. So you get 8 greater than or equal to 0. Is 8 greater than or equal to 0? Yes, it is. That's true. That means this whole section is true because x equals 0 was in the right section. See how we have a left, middle, and right section? So the whole right section was true. And remember, it goes true, false, true, or false, true, false. It switches back and forth. So this one must be false in the middle and true over here. Okay. And so now what's our answer? Well, our answer is the true regions. So this region, which is true, and this region, which is true. So, okay, so how do we say this? This goes from negative infinity to negative 4. United with. And this one goes from negative 2 to infinity. Negative 2 to infinity. Like that. Now, why did I use brackets? It's because of the bar here. When the original problem has a bar like equal 0, that's greater than or equal to 0. Equal means right on it, right? If it just said greater than 0, then it's just close to 0, but not right on 0. When it says greater than or equal, that means it's right on it. Well, that always means you have brackets, because a bracket means you're right straight on the answer negative 4. And the bracket here means you're straight on the answer negative 2. You're not just close to it. If I put a parenthesis negative 2, that parenthesis means you're around negative 2. You're close to it. You're like negative 2.01, but not right on negative 2. But when you use a bracket with a straight edge, you're straight on the number. And you always do that when you have an equals bar. So remember, bar here, this is a bar, right? Leads to bracket. BB, it goes together, bar, bracket. And you always put parentheses on the infinities, negative infinity, positive infinity, because you can never be straight on infinity. You're always just close to infinity. So there is our answer. Okay, so in this problem, we're supposed to graph this function. So how do we graph it when we have parentheses squared? Remember, it's opposite, same. So that means that's the vertex, the center of the U-shape, the parabola. So that's opposite. Opposite of negative 5 would be positive 5. And that's the x, because that's going with x. That's the x. And then the same as plus 3 would be plus 3. That's the y. Okay, so that means 5, 3. So over 5 up 3. Oh, I don't have room. Let me redo this on a fresh screen with a little more room here. Okay, there we go. Okay, so again, the vertex is opposite, same. So 5, 3 over 5 up 3. Right there, there's the vertex over 5 up 3. That's the center of the U-shape. Now, this is, remember, f of x, that's y. So where does the thing go from here? The vertex, so here it's 5, 3. The axis of symmetry is the line x equals 5. It's this line. Well, here, we'll do that in a minute. Let me hold off on that. How do we get the rest of the graph now? To get the rest of the graph, we need a second point. Remember how we always get that second point? It's the slope. And it's rise over run. Because this is y, we do rise first. So negative 3 over 1, that's my rise over my run. It's the slope that's in the front. Rise over run, minus 3 over 1. So that means you go down 3, go down 1, 2, 3 over 1. So right there is my second point. And now you just, that means the graph's going down. The U-shape is going down because the rise was negative 3. So it's going down, right? Whatever's in the front, y equals, I've got y equals negative 3 over 1. So that's y, that's down, down 3. So down 3 over 1, and then down 3 over 1. There is the graph of the parabola, and the x equals 5 is the line of symmetry. That's the line that goes right through the middle of the parabola. X equals 5. So how do we do this with parentheses? Opposite same gets our vertex, and then the slope in the front is rise over run, down 3 over 1 to get your second dot. Then you connect the two dots for the U-shape. Okay, so here on problem number 23, they give me a function f and a function g, and then they want f of g of x, and then in a minute they're going to have me go the other way. So what does that mean? Remember that functions always go right to left. So that means x goes into g, and g goes into f. So really what this means is f of g of x, like that. So that means I put all of g into f. So take all of g and put it right there into f. So we get 4, and then all of g, x plus 4, minus 9. See how that's all of g put into f? And then you can just work that out. That'll distribute. 4x plus 16 minus 9. That's 4x plus 7. There's the first answer. Now, for the second problem, they want me to go the other way, part B. They'll say, now do g of f of x. And so that means, x into f, f into g. G of f of x like that. So that means, let me put these back the way they were. That was 4x minus 9. 4x minus 9, x plus 4. minus 9. X plus 4. So now they want me to put f inside of g. So all of f will go right there into g. So that'll become 4x minus 9 plus 4. So I put all of f right there, all of f right there, and then plus 4. So that's pretty easy to simplify. That's just 4x minus 5, right? Minus 9 plus 4 is minus 5. And there we go. It's 23. Okay, so in number 24, they're asking me to find the inverse. Now, how do we find an inverse function? Well, there were two steps. Step 1, switch or invert x and y. So now where's y? Well, remember f of x is y. So I'm going to switch them. So I'm going to put x there and y there. So that'll become x out here and y over there. So there's step 1, switch x and y. Step 2 is solve for y. So get y alone. So how am I going to do that? Put this over 1, go diagonal, diagonal. So I'll get x times 2y minus 1 is 1 times 3. And then I will distribute 2xy minus x is 1 times 3 is 3. Now I'm trying to solve for y, right? Y is saying, here's y right here. I want to be alone, get rid of all this other stuff. So I'll grab this minus x and jump it to the other side. So that'll be 2xy is 3 plus x, right? When that minus x jumps over, it becomes a plus x. Last step to get y alone, so we're trying to do y alone, divide by 2x, divide by 2x. Boom, boom. There's the answer. That's the inverse function. Or, let me mention another way you can write that is you could separate both of those over the 2x. It's good either way. And if you do the second way, these will cancel. So that'd be 3 over 2x plus a half. That's the same answer. Both those are good. We can't cancel these x's back here because of the plus sign on the top. Remember, pluses and minuses glue things together, like shopping at Costco, making them a package deal. So I cannot cancel that x like that, but if I separate them into two separate fractions, then I can cancel these two because it's not glued to anything anymore. Either way, both these answers are good. Both are fine. You could probably just leave it this way on the multiple choice final. That's probably how that'll look. It's just like that. Okay, so number 25 is a log question. Now, how do we handle log questions? What do we do with log questions? Well, basically, logs are inverses, opposites of powers, exponentials. So, find the base. Where's the base? This number. Base just means bottom, like the base of a table is the bottom of a table. You know, find the base. So step 1, find the base and put base down. Put the base down and, well, there. Let me just write it out rather than some weird sentence. Second step is you put that base on both sides. You put the left side and the right side. Left side, right side in the power. So what's the base? It's x. So find the base, x. There it is. There's the base. Let me let me rewrite this. And then step 2 is the base to the left side, so x to the left side, and the base to the right side, x to the right side. So you make the x the base on both sides. And then step 3, cancel out base. Well, let me just cancel out the side that has base, log base b of whatever, blah, blah, blah. Those cancel. So these cancel because they're opposites. They're inverses of powers. That's what logs are. So these guys are opposites. They just cancel each other out. A power, a base x to the power of the log with the same base, they cancel each other out. So what does that leave us? 64 equals x to the third. Now, how do we solve for x? Well, that means x times x times x is 64. I would just guess on my calculator, try 5 times 5 times 5. That's too big. 4 times 4 times 4, that's it. The answer is 4. 4 times itself 3 times is 64. We got it. So how do you handle logs? You find the base, and you put the base down and power both sides, and then cancel out when the power and the log, when the bases match, they cancel each other out, because that's what a log is. It's the inverse of a power. Okay, here's question number 26. What they want us to do, they want us to write as a single log. They want us to take those two logs and make them into one log, a single log. Combine them together into one log. How do we do it? Well, notice the bases match, right? Log base 5, log base 5. So I can just make it 1 log base 5, like that. And, oh, yeah, this power, remember what powers do? They come to the front. So that'll be 4 to the third. And what does plus sign become? Times 6. Do you see what happened there? Remember, adding for 2 logs, an easy operation like adding, becomes multiplication, a harder operation for only 1 log. Remember the deal? Like, for 2 people, a job is easier. For 1 person, it's a harder job alone. So for 1 log, multiplication is a harder operation than just adding for 2 logs. And then this number in the front goes to the power. So what does that give us? Log base 5, 4 to the third, that's, what is that, 64 times 6. Use your calculator. What was that? 3, I'll do it, 360 and 24, is it 384, I think? Yeah, 384. So there we go. What did we do? We made it into 1 log using the properties. Adding for 2 logs becomes times for just 1 log, and numbers in the front go to the power zone. And then we just work this out. 4 to the third, that's 4 times 4 times 4 is 64, times 6 is 384. Okay, so here's number 27. Sketch the graph. So they're asking me, is it a parabola or is it a circle? As you look at this, which one is it, a parabola or a circle? Well, this one is clearly a circle because both letters are squared. Remember, parabola has 1 letter, second power. But a circle has both x squared and y squared. So this is a circle because both x and y are squared. So it's a circle. And what's the center? How do we get the center? Center is always opposite, right? The opposite of what's in the parenthesis there, plus 1. What's in the parenthesis with y? Nothing. So 1, 0 is the center of the circle. So, and then what's the radius? The radius is always the square root of the number on the right. The square root of 15. So which of the circles, so it's not that graph, not that graph, it's either B B or C. Which one is a circle centered at 1, 0? 1, 0 is over 1, up 0. That's C, isn't it? This one is at its center is over 0, up 1. This one's center is 1, 0. That's right. The answer is C.